Hello students, good morning. Welcome to online learning, standard 12, subject chemistry. Students, in the 12th standard chemistry, we are discussing unit number 6, which is solid state. And in the solid state lesson, using the previous video, we have seen that how to calculate the packing efficiency or packing fraction of a simple cubic unit cell. That was the concept we have seen in the last video class. And today, by using this video, we are going to learn about, or we are going to calculate the packing fraction or the packing efficiency of a body-centered cubic unit cell. Students, unit cells are of various types. You know already. What are they? Simple cubic unit cell, body-centered cubic unit cell, and face-centered cubic unit cell. For every system, we have to calculate the packing fraction. In the given space of the unit cell, how much amount of the volume is occupied by the constituent particles, that is given by the term packing efficiency or packing fraction. Okay, so now let us calculate the packing fraction for a body-centered cubic unit cell. Okay. Look here, this is the pictorial representation of the packing in a body-centered cubic unit cell. Okay, the namings are very, very important. Look here, all the corners are named from A to H. Look here, this corner is A, this is B, C, D, E, F, G, H. So all the 8 corners of the unit cell is named from A to H. Okay, and this edge length, as we have seen in the previous case. In the previous case of the derivation of packing efficiency for a simple cubic system, we have taken the edge length as A. Here also we are taking it as A. Okay, so length of the edge of the cubic box is A. Okay, and students, this picture is very, very important. By using this picture only, we are going to derive the packing fraction of this body-centered cubic unit cell. Okay, Vama? Okay. Is it clear? Okay. Now look here. In the triangle ABC, let us see where is the triangle ABC. Look here. Where is A? Here it is A. Here it is B. And where is C? This is C. Okay. Let us take this triangle. In the triangle A, B, and C. Okay, what dear students? Students, already you might have studied in your lower classes about Pythagoras theorem. What is Pythagoras theorem? The square of hypotenuse will be equal to the sum of squares of the other two sides. In a right angle triangle, the square of hypotenuse will be equal to the sum of square of the other two sides. Here, which is the hypotenuse? AC is the hypotenuse. So how can we apply Pythagoras theorem here? AC square. Can you able to understand? In the triangle ABC, AC square will be equal to AB square plus BC square. Is it clear, students? What I am telling? Let us take a triangle ABC. In that triangle, by applying Pythagoras theorem, we can write AC square is equal to AB square plus BC square. That is the first line I have taken. In triangle ABC, AC square is equal to AB square plus BC square. Okay, now this square, the square over this AC is converted into square root in the opposite side. So we can write AC is equal to square root of AB square plus BC square. Okay, now let us substitute the values of AB and BC. Again come to the picture. Where is AB? Look here, this is AB. AB is the length of an edge. And what is BC? BC is also the length of one edge. So instead of AB, we can substitute A. Also instead of BC, we can substitute A. Now this equation becomes AC, that is equal to square root of A square plus A square. When we add A square with A square, the answer will be 2A square. So we can write AC, that is equal to square root of 2A square. Now when the square root is applied separately for 2 as well as A square, you will get root 2A. So what we have got? AC, that is equal to root 2A. So we have got the value of AC. This is step number 1. Then again we are taking another triangle, which is triangle ACG. Let us see where is triangle ACG. Look here, this is A, this is C, and where is G? This is G. Let us take this triangle A, C, and G. Here also what we have to do? We have to apply the Pythagoras theorem. Here what will be the answer? Where is the which is the hypotenuse here? AG is the hypotenuse. So we can write AG square, that is equal to AC square plus CG square. Okay, look here, in the triangle ACG, AC square that is equal to AG square that is equal to AC square plus CG square. Now the same technique we are doing. AG square is converted into AG, so that square is converted as a square root in the opposite side. So we can write AG that is equal to square root of AC square plus CG square. Then AC value we have derived in the previous step. AC that is equal to root 2A. Let us substitute that value in this equation. So we can write AG that is equal to square root of 2A the whole square plus CG. CG is another edge length. So we can substitute A square. Okay, so square root of 2A the whole square plus A square. When this square root of 2A is squared, you will get 2A square. Okay, so AG that is equal to square root of 2A square plus A square. Then 2A square plus A square is equal to 3A square. So you can write square root of 3A square. Now A square you can take out from the square root. So this becomes AG that is equal to square root of 3A. Okay, so AG value also we have got. Two values we have now. AC that is equal to root 2A and AG that is equal to root 3A. Okay, by possessing these two values we can proceed further. Okay, we have two values in our hand. What are they? One is AC which is equal to root 2A and the one more is AG which is equal to root 3A. Okay, okay. Then we can have root 3A that is equal to 4R. Okay, why root 3A is equal to 4R? What is root 3A? Look here, AG that is equal to root 3A. Okay, so what is AG? Look in the picture. Where is AG? A is here and where is G? G is here. It is a diagonal line. Okay, now look here. This point is R. Okay, we are starting from A and moving towards G. Okay, this measurement is R. It is the radius of one sphere, so it is R. Now, this measurement, it is 2R. It is the diameter of this body-centered system, so it is taken as 2R. Okay, now come to the remaining. Now we have connected A to G. Okay, R plus 2R plus R. So clear, students? One more time let me explain. Look here, we are going to start from A. Here it is A and we are moving towards G. Here is G. Now the radius of this sphere is R. Now come to this body centered sphere. Here this is included. It is the diameter. Diameter will be equal to 2R, that we know. Okay, now come to the final sphere. It is R. So we can write R plus 2R plus R, totally that is equal to 4R. Okay, so AG that is equal to 4R and the value of AG we have found, that is root 3A. That is why it is written that AG, look here, AG is equal to root 3A. Now AG is equal to 4R we have seen. So we can write root 3A that is equal to 4R. Now what is R? How R can be calculated? R that is equal to root 3 by 4 into A. This is the radius. Okay. In the case of simple cubic unit cell, we have seen that R is equal to A by 2. Whereas in the case of body centered unit cell, the value of R is equal to root 3 by 4 into A. Okay, okay. Now let us calculate the volume of the sphere because we have the radius value now. Okay. Okay, what is the formula for calculating the volume of sphere, which is equal to 4 by 3 pi r cube. Okay, this is the formula of the volume of sphere. Now r value you can substitute. What is the value of r? R is equal to root 3 by 4 into A. So we can have volume which is equal to 4 by 3 pi root 3 by 4 into A the whole cube. Okay, okay. Now by simplification this will be converted into volume of the sphere that is equal to root 3 by 16 into pi A cube. Okay, okay. Simplification you know. Okay, or let me simplify and explain you. Look here, how can we write it? 4 into pi into root 3 cube. What will be the answer of root 3 cube? We can write it as 3 root 3. Is it correct? Root 3 into root 3 into root 3. How can we write? 3 root 3. Okay, into A cube divided by, here 3 is there, so 3 into 4 into 4 into 4. Now simplify, 4 cancelled. Then what is there? 3 cancelled. Okay, nothing else to cancel. So how can we write? Here pi and A cube is remaining. Pi root 3 A cube is remaining. Here what is remaining? 4 into 4, 16 is remaining. Okay, so now the volume of sphere becomes root 3 pi A cube divided by 16. This is the volume of one sphere. Okay, but in the case of body centered unit cell, how many atoms are present per unit cell? Which is 2. That also we have seen in the previous videos. Okay, okay. Now this volume has to be multiplied by 2. Okay, so we can write 2 into root 3 pi A cube divided by 16 and it becomes root 3 pi A cube divided by 8. Okay, okay. Now packing fraction. What's the formula for packing fraction? Volume of sphere divided by volume of the unit cell. What is the answer of volume of sphere? That is root 3 pi A cube divided by 8. Then it is whole divided by A cube. Now when we simplify it, what we will get? This A cube and this A cube gets cancelled and remaining root 3 pi divided by 8 into 100. Okay, okay. Now when this 100 is divided by this 8, it will be 12.5. The value of root 3 is 1.732 and the value of pi is 3.14. So we can write packing fraction is equal to 1.732 into 3.14 into 12.5. That is equal to 68. Here also into 100 will come. Sorry, not into 100. Okay, so what is the answer? 68%. Okay, okay. So how can we conclude? In the case of a body centered cubic unit cell, out of the volume available, how much percentage of the volume is occupied by the spheres? Only 68% of the volume is occupied by the spheres, remaining 32% empty space. So when we compare this body centered cubic arrangement with simple cubic arrangement, here it is somewhat closely packed than the previous case, than the simple cubic unit cell type. Okay, okay. So with this concept is over. Let us recollect from the beginning whatever we have seen in this video. Let us calculate the packing fraction for a body centered cubic unit cell. This is the picture of that arrangement of spheres in the body centered cubic unit cell. Calculation: AC value, AC is equal to root 2a and AG is equal to root 3a. Then root 3a is equal to 4r and radius is found to be root 3 by 4 into a. Now volume of sphere we have found and it is multiplied by 2. And finally, when we substitute the values in the packing fraction, we will get 68% as the answer. Okay, Mama? Okay. So with this video ends. You can have a clear understanding when you watch the video twice or thrice. Okay, our students, thank you. Learn well.